divide and conquer algorithm for the maximum subarray problem. My slides visible to everyone, right? Okay. So this is the change array. We have transformed the problem from the original array to the change array, and we need to show what is the range ij, like what is the contiguous sub array of this given array in which the sum will be maximum. So suppose this is the given array. If I equal to 0, j equal to 3, I equal to 0, j equal to 3, net profit is equal to 0, right? So if I equal to 6 and j equal to 8, still net profit equal to 0. So these are not optimal solutions. So how to find the correct solution? So correct answer in this case is I equal to 3 and j equal to 6. I think there is some typing mistake here. I equal to 0, j equal to 3, 4, 5. Oh, no, it's correct. I equal to 0, j equal to 3, profit would be 0. So the correct solution is this. So this is our input price change array. Output is a maximum contiguous subarray, low index and high index. Okay. So the constraint was this: I is greater than equal to 0, I is less than equal to n minus 1. That is size of the array. J is also the same range 0 to n minus 1, and j has to be greater than equal to I. The element must be next to each other. You cannot skip element. You have to choose the contiguous element. The challenge, there would be more challenging cases when you have some negative number like this, -3, -25. Why? Because the negative element will reset or reduce the total sum. So this is the problem statement, the problem description, the input, output, the constraint, and the edge cases. So input is an array of a number. Output, you have to give the maximum contiguous subarray sum, low index and high index. Given an array of given an array of integers, find a non-empty contiguous subarray ai to j, or the maximum subarray whose values have the largest sum. Max ak, k varies from I to j. Over all such possible ij, give the maximum contiguous subarray. So constraint on I varies from 0 to n minus 1, size of the array. J varies from 0 to n minus 1, where n is the size of array. J is greater than equal to I. You cannot skip any element. You have to choose the contiguous element. And if you have a negative number, that would be a challenging case because the total sum will be reset or it will reduce your accumulative sum. Goal is to maximize the sum to a contiguous subarray. So we can solve this using the brute force, divide and conquer, and dynamic programming. We can enumerate all the possible ij pair and calculate the sum from I to j. That will give us the brute force solution. In divide and conquer, we can break the problem into non-overlapping subproblem recursively, like divide the array into two parts. Okay, and optimal solution can be either in the first half, the left side, or the second half, that is right side, right half of the array, or a array subarray spanning across the middle. That will be given by maximum crossing subarray. Third type of algorithm design that can be applied here is the dynamic programming, where we will break the problem in overlapping subproblem, store the subproblem result and reuse it. So this is also properly known as cadence algorithm. So it is not in our syllabus, but it is often asked in our tech interview. So we'll see it in next class. The focus of this class is the divide and conquer algorithm for the maximum subarray. So let us see the brute force solution first. So this is the third brute force solution. Yeah, good question, Mohammed. J should be greater than equal to I in this case. This is the transform problem. In the earlier case, when you have the stock price, in that J would be greater than equal to I. That means that you cannot buy and the sell on the same day. Here, since we are taking the difference, J would be greater than equal to I. I hope now it is clear to you. So moving on. Here, curve sum equal to 0, start end equal to 0, 1. For all the pair I and J is starting from I plus 1. There is a third variable K that will loop from I plus 1 to J plus 1. Find the sum. If this curve sum is equal greater than equal max sum, then we'll reset max sum and we reset start and end. So this in this way, three loop, we calculate the maximum profit using the brute force solution. So can you guess the time complexity? Anyone, can you guess the time complexity for this? Is this a dependent loop or independent loop? Yeah, it is a dependent loop because J is dependent upon J range is dependent upon I, K range is dependent upon both I and J. So this is a dependent loop. Roughly, it will come order of NQ. Moving on, can we do better?
Good evening, sir.
Good evening, Shivendra. Can we do better? So instead of three
So
loop, can we do the
reduce,
things in
we
the
can
two loop?
reduce the we can reduce the third loop to the second loop and calculate the sum in itself only.
Yeah, good. Yes. So this is the brute force solution 4, where we have inside the first loop, we have a curve sum, and every time we are adding a new number to curve sum. If this sum is greater than max sum, we are resetting the max sum start and end. So without taking the third loop, we are looping over all the ij. What property we are using? Prefix property, because every sequence we have already the prefix sequence in the jth loop. So we are adding one element in the jth loop to that sequence. Any doubt in the brute force solution 4? Uh, if not, can I proceed? If anyone has doubt, please ping me in the chat or in the comment. Okay, good. No doubt. So we'll move to the divide and conquer solution. So let us visualize rather than actually solving it. First visualize. So we have a maximum subarray, that is our original problem S. We have divided into two sub problem. Say S1, find the maximum subarray in the left hand side, left half. Second sub problem, find the maximum subarray in the right sub half. This is our S2. This is our S1. And there is a S3. Find the maximum crossing subarray. So this crossing subarray must contain the element mid and mid plus 1. If this you focus on this picture, this is any subarray in the S2 part, that is the right subarray. This is the maximum subarray in the left part. This has to be in this region only. And third part, it has to span across the middle element. So it must contain middle and middle plus 1. It can extend this side, it can extend this side, but it has to contain mid and mid plus 1. And whichever out of these three sum is greater, we will return that maximum sum. So this is our intuition. We are breaking the problem into sub problem. the two subproblem of the same nature and one subproblem of slightly different nature. I'm just pausing. If you have any doubt, you can ping or comment. The intuition is clear to everyone. Can you please let me know? Then we can proceed if the intuition is clear to everyone. Can you all message if the in the chat or the comment if the intuition is clear to everyone? What we are trying to do. Good. Atvik, Mohammed, Pranadia, all of. So, okay. So good. Then let us see the pseudocode of maximum subarray. So these are the example. We'll go through one example from the previous year question paper. First, let us see the pseudocode of maximum subarray. So it is taking, this is the Python pseudocode written in Python. You can code in any language. For our lab, we'll use the C programming language. So this is the maximum subarray, a low high, and we have to formulate a recursive solution following the divide and conquer approach. So the base case will be if there is a single element, we return that element, a low, low, high. That is our base case. Okay, so recursions have the base case and recursive case. Otherwise, if it has more than one element, then we have multiple subarray possible, and then we have to see which subarray is or has maximum sum. So we'll first find the mid equal to low plus high by 2. So it is the integer value, not the fractional value, floating point. The mid is an integer. And then we will recursively call same function max subarray. It is marked at 1. Max subarray a low mid. So this is the left half of the array. We'll call the max subarray. It is returning three things: left sum, left low, left high. Similarly, we will call the max subarray on the right side with the parameter a mid plus 1 high. Let us call this function call as second. So essentially, we are calling here the max subarray on the right half of the array. This will return right sum, right low, right high. Third, we are calling a different function. This is not a recursive function. Max cross subarray a low high. Here we need to pass from low to high. It will return cross sum, cross low, cross high. Line number 6 to 9. I hope it is crystal clear to everyone. This is just code of this diagram. So this was the maximum subarray a low to mid was 6. Maximum subarray mid plus 1 to high. This is 8. This is 7. This is 8. And this is 9. So 7, 8, 9 is clear to everyone. Now, in this from 11 to 16, we are just comparing out of this sum, which one is greater. Left sum is greater, right sum is greater, cross sum is greater. Whichever is greater will return that sum. If left sum is greater than both right sum and cross sum, we return left sum, left low, left high. If right sum is greater than left sum and right sum is greater than equal to cross sum, we return right sum, right low, right high. Else we return cross sum, cross low, cross high. This pseudocode is very simple. A recursive, so that is the beauty of a recursive function. You can code a complex logic in very less sentence, very less number of lines of code. Code is very clean. Okay, so this is clear. Max sub array function is clear. Please
Yes,
respond
sir.
in the chat or the comment, or if you have any doubt, yeah, please ask. Any student was asking the question, sorry for interruption, please ask. Unmute yourself and ask. Yes, Tejas, if you have any doubt, or Pranav, anyone, if you have any doubt, please ask.
No, sir, clear.
Okay, thank you. So we'll proceed. So instead of finding no, so max cross sub array. So max cross sub array, it has to span through the middle. So middle and mid plus one will be the part, and then it will try to extend as much as possible in both left and right direction. So this is cross max cross sub array. We will first calculate the maximum sum possible in the left side. So mid equal to low plus high by 2, left sum equal to a mid. It means that we will always take this middle while calculating the cross sum. So left sum will always contain the middle. So left sum is initialized at a mid. Max left is initialized including, like from here, how much to include. That will be given by max left. And that we initialize with mid. Current sum is 0. The current sum is 0. Then we will go from mid to low minus 1 with the minus 1 gap. Current sum will add AI. If current sum greater than left sum is updated as current sum, max left is updated at I. So it means that from here we are trying to extend as much as possible. By default, left sum is mid and max left equal to mid and left sum equal to a mid. So once we have tried the maximum extension in the left hand side of the crossing sub array, which by default include the middle element, we got the left sum and the max left. Next, we repeat the same process in the right side. So right sum equal to a mid plus 1, max right equal to mid plus 1, cur sum equal to 0. Similarly, for j in range mid plus 1 to high with increment of 1, cur sum plus equal to aj. If cur sum greater than right sum is updated as cur sum, max right is updated as j. And we return left sum plus right sum because it has to span the mid and mid plus 1. So this is the total sum of the crossing array, left sum plus right sum, and the index will be the max left and the max right. Index will be the max left and the max right. So max crossing sub array pseudocode is clear. Thanks, Satvik. So anyone else, if you have any doubt in the max sub array or max crossing array, it will be more clear. We are going to show the running of the algorithm on one small example. It will be more clear. But for now, if you have any doubt, please let me know. Can I assume that is it clear to everyone? At least the intuition part, what we are doing in the max sub array, what we are doing in the max cross sub array. Okay. So this is the overall function of max cross sub array. Just look, we have shown half a part so that it fits into the slides. You can go through it once and then we'll show you the running of this algorithm on the actual example. If you want, you can take the screenshot of this. Also, you can take the screenshot of this function. Moving to a one problem. So this was the last year problem. So can you note the array in your notebook and then we'll solve together. So I'm giving you 2 minutes to start your solution and then we will solve together. Please note the element and try to do this problem now. You have seen the pseudocode. For 2 minutes, you try on your own and then we will do it together. Let me know if you have noted the problem statement. Have you noted the problem statement? Okay, good. So just try to have the solution of this using the pseudocode that I have shown you and try to visualize in terms of recursive call graph. So how do you present your solution? So try to draw a recursive call graph for this. Have you tried? How many of you have tried this? Should I wait for 1 or 2 minutes, or should I start discussing the solution? Okay, once we'll start part by part and let us do it together. Yes. So let us note the array first. So we'll not do the complete solution in one go. We'll build up step by step. We'll try to understand the solution also. So let us note the array first. So our array is -2, -5, 6, -2, -3, 1, 5, -6. Let us call this array as A, and let us write the index below the element. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So we have an array of 8 elements ranging from 0 index from 0 to 7. And let us use two abbreviation. One abbreviation will be the MS for maximum subarray. So MS for maximum subarray, we will use MS abbreviation in the call graph, and let us use MS for maximum subarray and MCS for maximum crossing subarray. So maximum crossing subarray. So let us use these two abbreviation. So first call, what will be the first call? First call will be MS A07, right? Maximum subarray from 0 to 7. So what it will do, it will just find the mid. So mid will be equal to 0 plus 7 by 2, the integer part, so 3. So for the sake of clarity, let us divide the array into two parts, right? Not in the recursion call graph we need to divide, but for here we will divide. We are trying to understand the solution. So let us divide the array into two parts. So one part -2, -5, 6, -2. That is from 0 to 3 we have taken in one part, 0, 1, 2, 3. Over this array, we will repeat it like no recursively call MS MS A03 on this subarray. Okay, that is our first recursive call. Then second recursive call will be MS MS. What will be the second recursive call? Help me with this. Let me see how much you have understood. This is first part is MS A03. Maximum subarray A low mid. Good, very good. So this so this will be A47 mid plus 1 and the end. So A47. So let us copy the element. So element are -3, 1, 5, -6. Let us copy the index below. So this is 4, 5, 6, 7. Okay. So this again we will recursively break this, like the from A0 to 3 we will again break into two halves. Similarly, we'll break this into two halves. But for the sake of understanding how we will do, let us not break. Let us just tell me what will be the maximum subarray from this first part. What will be the answer maximum subarray from this half? You just manually see all the combination and tell me what is the best part from here. So only 6, good. Anyone else? Any other possibility? Any other possibility? Please interact. Okay. So what will be the maximum subarray from this part? This part, just see all the possible combination and tell me. In the program, it will recursively break, but we don't want to break it further for now. Just tell me. So 4. Okay. So 4 is less than 6, right, Mohammed? A2 plus A3, that will be 4. So 4 is less than 6. We want to maximize the subarray. Maximum subarray. So most of you have answered that we are getting the 6. So 6 is we are getting 6 from here. And what is the index value? Index value will be 2, 2. Low is 2, high is 2 from this. Okay. And this part, the second part, can you tell what will be the solution from this second part? The maximum subarray? Good, 1, 5. 5 minus 6. Dhruv, you are missing the minus sign. That is 5 and minus 6. So it will be total sum will be -1. 1, 5. Yeah, most of you are getting 1, 5. So sum will be 6 and low and high will be 5 and 6. Okay. Now let us understand the third part, the MCS. We will call MCS. And what will be the parameter? What will be the input to the MCS in this step? So let us call this as third call MCS. What will be the input? So one call was this, one call was this, other call was this, and it is calling third call. So what will be the input in MCS? Good, Pranath, very good. So it will have A07. So let us copy the whole array for once, and then let us see how we are calculating the crossing sum. 6 minus 2 minus 3 1 5 minus 6. Okay, we have copied the index. Now what is the mid value? What is the mid value here? So mid is pointing 3. So we have to find the maximum crossing sum, and crossing sum must include this element the middle element and middle plus one element. So we'll start from here and we'll try to extend as much as possible this sign, the left side, and maximize the sum. So how you will do? So let us initialize the max right sum as a mid -2 and cur sum equal to 0. So we initialize cur sum to 0, max, okay, max sum left equal to a mid, that is -2, and max left is equal to mid, that is 3. So this is our initialization. Then we will look through, we will add 0 to -2. -2 is not greater than -2, so we'll keep this. Okay, so basically we are looping from here to here. We are trying to extend this. We have already considered, so same value. So we are not increasing this value. Now we will try to increase from here to here. So 2 and -6. So cur sum will be 0 plus -2 plus 6. Cur sum will be, what will be the cur sum from here to here? I think you are giving the total answer. Let us see. 2, 3, 5, sum 2. 2, 3, 5. Are you talking about the crossing sum, Atvik? For the call of part 3 MCS A07? Total sum. So let's see, we are going to process. So we are including this -2 and 6. So the sum we are getting -2 and the 6, that is 4. The previous max sum left was -2, so it will be updated as 4. And max left which will be updated as 2. Okay. Now we will include -5 also. Try to include -5. So -5 means 4 plus -5, that is -1. So that is not greater than this. So we will ignore this. Okay. So cur sum will be 4 plus -5, that is -1. -1 is not greater than current max sum left 4. So we'll ignore this. Then we will try to include -2, -1 plus -2 -3. This also we are not getting satisfied result. So we'll exclude this. So we are including up to here -2 and 6 in the left side. 6 and -2 here. Similarly, we'll proceed in the right side. Is this clear how we are proceeding in the left side for maximum crossing sum? Is this clear for everyone? Because this is symmetric. If the left side is clear, right side will also be clear. So I just want confirmation from all of you. If there is any doubt, I can repeat. Good question, Pranat. He's asking if we see that -5 is not satisfying the condition, do we need to still check for -2? Of course, yes. Suppose instead of -2, there would be 14. Although there was -5 plus, suppose here is 14. So this 14 addition would overcome this negative. And that's why we need to check for. I hope I answer your questions. Okay. So similarly, we'll proceed in the right side. So right side cur sum will be initialized again. So cur sum in the right side will be 0. Max sum right max sum right is equal to a mid plus 1, that is minus 3, and max left equal to max right equal to 4. Now we'll try to include this. So this of course is the same value, so we don't care. Now we try to see this value. We try to see this value. So this value equal to 3 minus 3 plus 1, that is minus 2. Minus 2 is of course greater than minus 3. So this will be considered. Then we try to see this value minus 2 plus 5, that is giving 3. Of course this 3 is greater. So this will be also considered. Then 3 plus minus 6 minus 3, this is lesser than minus 3. So this will not be considered. So here on this side, we are extending from this side till 5. This side 6. So 6 we are including, 2 we are including, this we are including in the left side. In the right side, we are including minus 3, 1, 5. So net sum, what is the net sum of the crossing array? What this will return? What this will return? This will return the maximum sum as 7, and the index value it will return as, what will be the index value that it will return? 2 and 6. So out of this, so this has returned, this first has returned what? The maximum sum of this was 6. Index value was 2, 2. This has returned the 6. The index value was 5. Index value was, what was the index value here? 2, 6. So out of 6, 6, 7, which one is the maximum? Coming back to your question, Mohammed, yeah, very good questions. That your Mohammed is asking why we are calculating maximum subarray if we are already calculating MS in the left part and MS in the right part. Have I understood your questions? Or you are asking why we are calculating recursively? Why we are breaking function 1 again, function 2 again? Can you clarify your question once? You can unmute also, Mohammed. You can unmute and tell your questions. Just I have a doubt. Yeah, so MCS part alone is enough. Okay, okay. Now you got. So Mohammed is asking MCS part alone is enough. Why we are calculating 2MS recursively? What is the constraint in MCS? So anybody would like to answer this question? If the MCS itself is giving the correct answer as in this, why do we need to calculate 2MS recursively in the left hand side? Good, Dhruv, good, Dipanshu. So both of you have answered correctly that there is a restriction in maximum crossing sum, that it must include the mid and mid plus 1, and it has to span this. It has to be contiguous. It cannot ignore mid and mid plus 1. So if the maximum subarray is only in the right half, then only calling MCS will not give the correct answer. Similarly, if the correct or the maximum subarray in the left part, only calling the MCS will not give the correct answer. So don't get biased by this example alone. This is just one example. So MCS is not a recursive call, and MCF has a restriction that it must include mid and mid plus one. Are you trying to ask Priyansi that only MS is sufficient, like maximum subarray is sufficient, maximum crossing subarray is not required? Or you want, or you are asking different questions? Can you please clarify your question? Priyansi, can you clarify your question? The same question, you have just paraphrased the question of Muhammad Ilyas. First thing, MCS is not a recursive function. MS, inside MS, we are calling two MS and one MCS. We are not calling MCS inside MCS. Second, MCS has a restriction that it must span through the middle element. It must include mid and mid plus one. If MCS does not include mid or mid plus one, if it does not span through mid or mid plus one, then it will be part of either left subarray or the right subarray. Essentially the MSA03 or MSA47. Let us draw the first, let us complete this example. The more example we solve, the more clarity we'll have. So we have not solved this example completely because we have not called recursively. So just for the sake of understanding of the pseudocode, we have, instead of recursive call, we have solved manually the MSA03 and MSA47. So out of these three, the maximum is 7, right? So this will be returned as final solution from this, and subarray from 2 to 6. So this subarray will be returned as a maximum subarray with a sum of 7. So that is the solution. But how to draw the complete recursive call graph and how to solve completely? So let us try. I will write some of the steps and then you can write the remaining steps. So again, we have to copy the array first. So let us copy the array. Okay. So let us -2, -5, 6, -2, -3, 1, 5, 6. Let us index the array 0, 1, 2, 3, 4, 5, 6, 7. This array we are calling it A, and we are calling the function MSA0. Okay, so we are calling the function MSA07. So this will call three function. Okay, this will call three function. First function will be the MSA03. MSA03. Then it will call another function. What that will be the MSA47. And in the intermediate, it will call MCS. MCS A07. So this will be the first function that will be called. This is the second. This is the third. However, you can call in any order, because only once we have calculated all three, we'll calculate which of these three is maximum. So as per the pseudocode that I have shown you, we have first calculated this, then the second, then the third. The calling order. Okay. So, but will not like, no, first we'll expand it, while the recursive way will not complete this, we'll complete this first. Okay. So again, we will break. This is not a single element, 0 to 3. There are more than one element. So we'll again break this as MSA01 and MSA23. Is this clear? So let us not try 2, 3 here, because this one followed by 2, it will complete this. So it will go in this order. So that numbering will do at last after drawing the complete tree. So again, this way will break. So this way will break like MSA 4 plus 7, 11 by 2, that is 5. So this is 4, 5. And this is MSA 6, 7. So still this has two element, 0 and 1. So this is still not single. So we have to break it further. So what will be the value here? The value here will be MSA00 and MSA11, and the middle element MCSA01. Similarly, we have to break this. The MSA22, MS. I hope this is visible. Due to the space, I'm reducing the font size. I think you are able to read the text. If not, please let me know. So this is little clumsy, but I hope you can understand this. So now this will break. So here it will return. You have the element 0, 0. So 0, 0 is -2. So what it will return from here? It will return -2 and along with 0, 0. Is this clear? So it will call 1, 1, 2, and then followed by here it will call 3. Then it will call 4 here. So MSA11, so single element. So it will return 1, 1 -5. So it is going to return -5 and along with the index 1, 1. Okay, and MCS 0, 1. So 0, 1, it is going to return the mid and mid plus 1. So it is going to return 2 and -5, right? So 2 and -5, what will be the value? -7. So it has to include mid and mid plus 1, both. So it will be -7. It has to return -7. And the index 0 and the 1. So out of these three, -2, -5, -7, which is maximum? Out of -2, -5, -7, which is maximum? Are you asking any question, Muhammad Ilyas? MSA03. So -2 is maximum. So -2, it will return, this function will return -2 here and with the index 0, 0. Right? Similarly, this side after completion of fifth. Okay, here, yeah, correct. You have pointed correct. We have missed one MCS here. We have one MCS here. MCS A03 and here also one MCS A47. So I have more clear version that I have already drawn. So if the process is clear, just give me 1 minute. I will scan that solved version and then share with you. Give me 1 minute. The process is clear to everyone. Is the process clear to everyone? Can you see the solution now? My screen is visible. Is it visible now? So ignore this 0, 1 knapsack, that is not part of the solution. So this is the solution. You have to draw a tree like this. Let me, so I'm zooming from the top and then we'll go down. So like this, you have to draw a tree in your cat answer key. If I try to minimize a little bit. Yeah. So this 0, 1 knapsack, and this is the fourth question. So ignore this part. Any doubt here? Anyone has any doubt? Okay, good. So now this algorithm demonstration is clear. Yeah, we are coming to time and space complexity. So this, how to draw the recursive call graph, how to find the solution. Is that clear? How to draw the call graph, is it clear to everyone? Okay, so now it was asked to draw the call graph and solve this. So basically the solution, you just need to show the call graph and this is the final solution. And you need to show the algorithm, so pseudocode. So this pseudocode you could have written this, the max sub array a low high with the recursive call. So this you have to show this. Followed by the complete maximum subcross array. This you have to write. And then using this, you have to derive the time complexity. So since this is a recursive call, can somebody write the recurrence relation for this recursive call? So how much time maximum cross sub array will take? What would be the time taken by maximum cross array, cross sub array? What will be the time taken by this function? Correct, Pranav. It will be order of n. From mid, we are going till the low -1. From mid +1, we are going high. So it will be order of n. And what will be the recurrence relations from here? Recurrence relation for the maximum sub array. What will be the recurrence relation? Yeah, correct, Dipanshu. Pranab, you have to also write Tn equal to 2Tn by 2 plus theta n or big O of n or even n. Both of you are correct. So this recurrence relation will be this. So this is base case. This is for the base case. This is max sub array for right and left half. This is maximum crossing array. This is to combine the solution because you are just comparing So this will be the recurrence relation. In total, we can write like this. So first theta1 is for comparing whether it is a base case or not. Maximum of base case and recursive case. So recursive case will take more time. So this is the recursive case 2tn by 2 plus theta n. And then to combine the solution, we have to compare once. So theta 1. So recursive case will take this. So this is very known recursive relation. You can use either master theorem or recurrence tree method. So what would be the final solution? N log n, right? This recurrence relation you have solved in your DSA. You can use either master theorem or recurrence tree method. So using divide and conquer approach, our time complexity is n log n. Space complexity is order of 1, where the brute force was giving n square solution. Anyone has any doubt? In time and space complexity? Thank you everyone for your patience. If you have a doubt, please ask. We'll wrap up in 2 minutes now. Anyone has any doubt? Please respond in the chat if you have any doubt. Yeah, so correctness proof is also there. So it has the rough sketch of the correctness proof that we'll discuss in the other class. So you can do more homework by recursive call on this graph. So it will clarify and it will boost your confidence. These are the different array and you can try to do the recursive call graph on this array. And these are the correctness proof outline. We'll discuss this separately in next class using induction, inductive step for the recursive thing. We'll discuss it separately. Okay. So why we are using the divide and conquer here? Because we have a non-overlapping substruct, not non. We have a sub problem that are non-overlapping, and okay, so it is giving better than the brute force, but still cadence algorithm using the dynamic algorithm will give much better in O1. That also we'll see in the next class. So advantage of the divide and conquer, each of the recursive call can be done in parallel because left and right sub problem are independent. So we have independent sub problem. This is structured and intuitive, making it easier to understand and implement. It is more efficient than brute force. So it can be used, divide and conquer, it can be used in multiple places: financial analysis, weather and data analysis, signal processing, data analysis, genomics. So these are the practice problems. This we have already discussed, so we'll wrap up this. Okay, just go through this and then we'll continue in the next class. So you can see what are the characteristics of divide and conquer, where we can apply divide and conquer, where we cannot apply divide and conquer. Recursive call graph, sure. So this is the recursive call graph. Yeah, it is not that you have to know only the best method. You have to learn the design method. Why in this case divide and conquer is applicable? Why in this case dynamic programming cadence algorithm is applicable? So in real time, suppose you are asked in interview, solve this question. At that time, he will not specify which algorithm. Or even in the OA round, online assessment coding round, they will just give this. But brute force will not pass all the test cases within time limit. but may still pass some of the test cases. So you will get partial answer. Suppose you forget the cadence algorithm, but you know this divide and conquer that is little slower than the cadence, but that will be still do the job and may pass the test cases within the time limit. And even you can clarify the or clear the interview. Suppose you forgot somehow something in the cadence algorithm. It is not that one algorithm is better than we don't have to study the suboptimal algorithm. We have so many sorting algorithms. So based on scenario, one algorithm is better and one algorithm is not better. Yes, Python syntax is acceptable for pseudocode until unless they tell the code. So mostly they tell the pseudocode or the algorithm. But in the lab, you have to code using the C language. Another advantage of the divide and conquer that each of this recursive call can be calculated in parallel. So we'll stop here. Thank you, everyone. I hope nobody has any objection. I will upload this to YouTube and I will share the link. I'm planning to have a course page in the GitHub where I can put everything in a more structured way. Thank you for your time. Thank you for your effort. Please practice this. This will carry at least 10 marks in your internal exam. So one question from either this maximum subarray or the Karasuba fast integer multiplication. So one question will be there from this. Thank you, everyone. Good night. I will stop the recording. If anybody has any objections for the recording or for sharing the video, please let me know. So I'm stopping the recording now. Thank you, everyone.